Did my lessons wrong. Your unit exam is Tuesday of next week. We have one lesson today, we have one lesson tomorrow, review on Friday, review on Monday, exam Tuesday. So when you're solving trigonometric equations that are quadratic, the idea is you want to reduce them in some way to linear quadratic equations. So for example, if you take a look at D up here, this is like having a squared minus 2a minus 3 equals 0, which would factor into a minus 3a plus 1. So this factors into secant of theta minus 3 secant of theta plus 1. And then you can set each of them equal to 0, each of those factors equal to 0. So this would be secant of theta equals 3 when we set that equal to 0. When we set this equal to 0, it would be secant of theta equals negative 1. And then you're not quite in the realm of a grade 10 or 11 question because those are reciprocal trig ratios. But you can proceed in that direction by writing this as cosine of theta equals 1/3 and cosine of theta equals 1 over negative 1, which is still negative 1. And then you proceed from there. Okay. With the cos equals 1/3, 1/3 is on the unit circle somewhere, but you don't know the coordinates of the point or the angle that gives you that x coordinate. So you would have to use your calculator along with the idea of a reference angle. Cosine equals negative 1 not only is on the unit circle, but it is a known location. It's at pi radians or 180 degrees. So you don't have to use your reference angle and calculator setup in that fashion. So let's spend some time going over some trig. Any questions you'd like me to go over? Go ahead, Kendra. Okay. The likelihood that you would see this on my exam is basically 0. The likelihood that you would see this on a diploma exam is close to 0. But you also need to appreciate, and I've mentioned this before, that I am teaching to students who will be taking calculus as well. So I think if you missed this explanation, you would never be harmed in any way in this course. I really don't think you'd even see it on a diploma exam. When you have an equation that has 4 terms, it's always a good idea to see if you can factor by grouping, which takes us way back to grade 10. And it's a method of factoring that you use so seldom, you might have even forgotten about it. The concept here is you group the 4 terms into 2 pairs. There's one pair. The other pair is negative cos x minus 1. And I don't know who you had as a Math 10 teacher, but when you factor by grouping, I hope they emphasize that you always want a plus in here. You never want a minus. And then what you do is you factor the greatest common factor out of the first pair. And in this case, I can factor out a 2 sine of x. And I would have left out of the first term cosine x plus out of the second 1. So I'll give you a second to mentally digest, everybody, why that's the first pair factored. If you want, you can convince yourself that it's right by multiplying this back in. And then you're going to do the same thing with the second pair, except your goal is not just to factor out a greatest common factor. Your goal is to be clever about it and factor out whatever you need to be left with the same thing you were left with out of the first pair. So if I want to be left with cos x plus 1, I can factor a negative 1 out of this second pair and be left with cos x plus 1. And if you go on and take calculus with me, this is something that I will mention many times or ask many times. I will ask how many terms are there on the left side of this equation? And the answer is 4. If I ask you now, how many terms are on the left side of the equation here? The answer is 2. This term minus this term. And what I do now is I think of those two terms, as awkward as they are, and say, is there a common factor that they each have? Well, yeah, they each have a factor of cos x plus 1. So I can extract that by factoring and have cos x plus 1 multiplied by, well, what do we have left out of this? 2 sine x minus out of this 1. And I'm just curious here, for those of you that are following this, how many of you, and you might not be able to explain why, would have written these two factors the other way around? I don't know why. When you look at this, most people go 2 sine x minus 1 times the rest of it. Anyway, now we're at the stage where you can set this factor equal to 0 and this factor equal to 0. And, you know, as much as the teacher in me wants to go, and you should be able to solve it from there, I've come this far, I might as well finish it. Okay. This becomes cosine of the angle is equal to -1. This becomes sine of the angle is equal to 1 over 2. Again, I suppose you could find a reference angle here and then look in these two quadrants where cos is negative. And you could find a reference angle here and look in these two quadrants where sine is positive. But kind of putting it all together, on the unit circle, first of all, cosine is an x coordinate. Sine is a y coordinate. So where on the unit circle is the x coordinate -1? In this location. Where is the y coordinate 1/2? Well, there's a half. This is 1. This is a half. So here and here. And then you can, say, well, pi over 6, 5 pi over 6, and pi. I don't know. I didn't even look at what the domain was. It said to the nearest 10th or 100th in decimal form for radians, so we could actually just take pi divided by 6 on our calculator and read what that number is. So I want to make sure, because that's a slippery idea here. If you say that x is pi over 6, that's the exact value. To find the decimal approximation, you literally take the number pi on your calculator and divide it by 6. Okay. Yeah. Okay, so we're good then? Okay. Other questions? Sasha. 21A. Okay. So it says, give the answers as exact values where possible. And all that means is we're going to be thinking of the unit circle. And, although there's an infinite number of points on the unit circle, we're only going to be able to write exact values for certain of those points that we're familiar with. Does that make sense? Okay. So I just need to pick your brain a little bit here, Sasha. You understand that 21A is similar to this equation. Okay. My next question to you is, do you feel that you need to write it that way to factor it? Okay. So ignoring this then, I'll leave it up because some of you might look at it. You would say that I need a sine of theta here. I like the textbook because they use theta instead of x, mostly. I need a sine of theta here. And I need, since the coefficient of this quadratic term is 1, I need to find two numbers that multiply to give -2 and add to give +1. And that would be -1 and 2. And I think I kind of see where I got it backwards. No, I got it forward. Correct. I think I see maybe where your question is coming up. Okay. You're good to there? Okay. When we write sine of theta minus 1 equals 0 and sine of theta plus 2 equals 0, we are doing that because if the product of, I'm reviewing something here, if the product of two things is 0, then either of them needs to be 0 to make that true. 0 times I could care less or couldn't care less is still going to be 0, as long as one of them is 0. So you end up with sine of theta equals 1, and you end up with sine of theta equals negative 2. And would it be safe to say that you were aware that the rotation angle here is pi over 2 rads, or 90 degrees? So we're just thinking of the unit circle, and we're saying where is y, because sine of a rotation angle is y on the unit circle. And we're going to have to really grapple with that today, with today's topic, because we're going to have y and x in some things that are different than y and x in the unit circle. But your struggle, I think, is here, isn't it? Okay. And that's because you're saying to yourself, where on the unit circle is the y coordinate negative 2? And the answer is it isn't negative 2 anywhere on the unit circle. It can't be, because the unit circle has a range of y values from and including negative 1 up to and including positive 1. And that's going to also be important for today's topic. In other words, the sine of an angle, any angle, positive, negative, rotation, reference, I don't care, radians, degrees, the sine of an angle can never be outside of that range. Okay? So even if I say to you an angle has a sine value of 1.05, it's impossible. There is no angle with that sine ratio. And the same with cosine. And I'm going to say something here that some of you might take issue with, because cosine is x on the unit circle. But I'm going to say the range of values for cosine, forget about the unit circle, the range of values for cosine is from negative 1 to 1. Because we are about to translate this to a graph showing sine and cosine. So, have I answered your question?
How would you write the answer to that?
Oh, if this were written response, you would need to communicate why you know this is the rotation angle that makes that equation true. You would say the y coordinate on the unit circle is positive 1 at pi over 2 rads. You could do that. And then over here, what you would do is you would put into words what I just said, that the range that since, and now I'm really touching on today's topic, okay? Since that is true, sine theta equals negative 2 has no solution. That would be your justification by using the proper language. At this level, I think, particularly after today's lesson, if you just said to yourself, I'm just going to say, not possible, I don't know that that's full marks. I think you need to elevate your response to, well, a Math 30 sophistication, right? Because if you just say not possible, I might say, well, is this person saying it's not possible because all they did was this? They even put the negative in, and they got an error, so they're saying not possible? Because if that's the only reason, then they don't understand. By the way, whether you put the negative in or not, you'll get an error. You okay with that? Okay. Other questions? All right, we have, in this course, when we talk about y equals AF of B bracket x minus h n bracket plus k, we've used this a lot. I mean, we've kind of learned it within the first 2 or 3 days. And at every turn, wherever possible, I've suggested to you that as long as you know what an original function looks like, you should be able to tell me everything about this function. So for example, we learned that y equals root x looks like that. And if you know that picture in your head, you know the domain and range and all of the features of that graph. So if I say to you, what does y equal negative 1/2 root 3x minus 9 plus 12 look like? You can go through all of the motions and say, well, it looks like this original graph after being stretched vertically by a factor of 1/2, reflected vertically across the x-axis, stretched horizontally by a factor of 1/3, shifted 3 to the right because you have to factor that 3 out of the 3x minus 9, and then shifted 12 up. Well, what we're going to be doing today is the same thing with these two graphs. You need to become intimately familiar with what this graph looks like and what this graph looks like. And if you take a look at our objectives today, we're talking only about introducing a and b to these functions today, not h and k. And in fact, we don't call them h and k, we call them c and d. But we'll deal with that tomorrow. Okay? The issue that you have to wrap your head around right out of the gate is when I talk about the cosine of an angle, if I'm going to use my unit circle, I'm looking at an x-coordinate on the unit circle. But the x-coordinate on the unit circle is not the x value that's in this function. Similarly, the y value on this function has nothing to do with the y-coordinate of the unit circle. It's just the y-coordinate on the graph of y equals cos of x. So you have some things that you have to struggle with here in terms of x and y. But we're going to start off by looking at what y equals sine of theta or sine of x looks like. This is the function f of x equals sine of x. And this shouldn't be difficult for you to figure out because now I'm going to walk away from that and go to the unit circle. On the unit circle, sine of a rotation angle is y, correct? The rotation angle on the unit circle is x on this graph. So when the rotation angle is 0, what's the sine? Well, it's the y-coordinate on the unit circle, which is 0, which is why this graph goes through this point. Because when theta is 0 rads, sine of theta is 0. What happens to the y-coordinate on the unit circle as you start climbing towards pi over 2 rads? Well, it starts increasing. The y-coordinate starts increasing, and it maxes out at 1 on the unit circle. So sine of x, sine of theta, if you like, will reach a maximum of 1 at pi over 2 radians. And once you pass, again, the rotation angle here is x there. Once you pass pi over 2, the y-coordinate starts dropping again until you get to pi, where it's fallen to 0. And then, past pi, the y-coordinate, which is the sine of the rotation angle, minimizes or valleys, drops down to a lowest point of -1, and then it rises back up to 0 by the time you get to 360 or 2 pi. And we know all about coterminal angles, so it makes sense that if we have this, really, a little early in the day for my computer to freeze, but we'll hope it catches up. If we have that from 0 to 2 pi, and we know that if we drop 2 pi from any angle, we get a coterminal angle, or if we add 2 pi to any angle, we get a coterminal angle. And a coterminal angle has the same sign, because it's in the same location, it makes sense that this repeats. This is what's called a periodic trigonometric function. Not all trigonometric functions are necessarily periodic. I only say that because some of you will take calculus. And this thing continues in both directions. Okay? What I would like you to add to this is just an indication that this point here is called the start point. This will be helpful tomorrow and in the next unit where, trig is not over after this unit. We have one more trig unit. That's the start point. And by start point, I mean at the beginning horizontally, it starts at 0. Okay? So, again, looking at the unit circle, at a rotation angle of 0, the sine is 0 because the y-coordinate is 0. And this is supposed to be a graph of y equals sine of the rotation angle. So it starts at 0. Where does cosine start? Well, cosine starts at 0 radians, but the cosine of 0 is the x-coordinate, which is 1. Which means that the start point for cosine, just to jump ahead, is 1. This is the start point. Cosine starts at the top and decreases. It starts at the top of this graph because cosine at 0 radians has a value of 1, and as the angle increases, that value of cosine, which is the x-coordinate, gets closer and closer and closer to 0. And then once you pass pi over 2, the cosine passes 0, and it becomes negative until it becomes negative 1, the x-coordinate on the unit circle. And then if you keep going, it increases from negative 1 until it gets back to 0, and then it continues to increase to 1. And then it decreases to 0, and it decreases to negative 1, and back to 0, and back to negative 1. So it cycles up and down as well. The difference is it starts at 1. At 180 degrees, cosine is negative 1. These are things you should know, that cosine of pi is negative 1 by looking at the unit circle. So now we're going to introduce some terminology. This is the graph of sine of x. What is the domain and range? Well, the domain is that the rotation angle is any real number. All right? And you can't hide from that x and y problem. You could change x to theta, but you would still write y equals sine of theta. What's the range? Well, the range of that graph, if you look at it, and I'm going to add something here that you do not need to add, and I prefer that you didn't, but it will be useful later, that there's a maximum value and a minimum value. This graph is corralled vertically between negative 1 and 1. Okay? And by the way, it's symmetrical this way. Not a mirror symmetry, but it goes just as high above the x-axis as it does below. So the range, and this is what I was talking about with your question, the range of sine of x is that negative 1 is less than or equal to sine of x, which is less than or equal to 1. Y is sine of x, so I could have written here negative 1 is less than or equal to sine of x, which is less than or equal to 1. Those mean the same thing. It's just instead of writing y, I'm writing what y is equal to. State the x-intercepts. Well, the x-intercepts are where y is 0. So where sine of x is 0. Sine of x is 0 here and here on the unit circle. So anytime we are at those locations, sine of x will be 0, which means the x-intercept should be at 0, 2 pi, 4 pi, 3 pi, negative pi, multiples of pi. But we can take a look at that. 0, pi, 2 pi, 3 pi, negative 2 pi, negative 3 pi. So what we can put for the x-intercepts, the x-intercepts are multiples of pi, where n is an integer. What's the y-intercept? Well, the y-intercept is 0. And I just want to stress to you, the most important part about that y-intercept is the graph starts at the origin and it goes up. Okay? What are the maximum and minimum values? Sine of x has a maximum value of 1, and sine of x has a minimum value of negative 1. You know, we can trace that to the graph, or you can look at the unit circle. Sine of x is between negative 1 and 1, and including negative 1 and 1. We have some other terminology, though, here. The period we use the symbol K for period, and this K has nothing to do with a vertical translation. Okay? The period is the length of, I would say if this were a physics class, is the length of time it takes for something to repeat. So when you're talking about a mass on a spring bobbing up and down in physics, the period is the time it takes for it to go from the maximum down to the bottom and back up to the maximum. The only problem is this is not a graph showing time, it's a graph showing x. But to go from here, which is the maximum, to over here, which will be the next maximum, is going to be the same as the time from here to here. That's the period, whatever that is. And if you look at it, that's 2 pi. But I want to explain it in a different way. So the period is 2 pi. I want you to focus on the following visual idea. A period, and I think this makes sense just in words, the period is one cycle. So this is the period. It's one complete cycle. Do you get my drift here with the word cycle? Okay. One complete cycle will always have 4 pieces. If you look up here, down, down, up, up. 4 cycles. And it doesn't matter where I start. I could start here. Up, down, down, up. Well, from here to here is the period, which is 2 pi. So any complete cycle is the period. And lastly, we have something called the amplitude. The amplitude is the vertical distance from the middle of the graph to the top or the bottom. Well, we already know it goes from -1 to 1. So the amplitude must be 1, because it goes 1 above the x-axis, which is the middle, and 1 below. What we can put on our graph here, as if you haven't already labeled enough, is that this is what we call the amplitude. Capital A. And capital A is not necessarily the same thing as little a, but it might be. So the amplitude is equal to 1. Take a look at your graph of cosine. I've already explained why it looks like what it looks like. The question is, what is the domain and range? Well, the domain and range of this graph is the same as the domain and range of y equals sine of x. The only difference here, I don't know if you can see it or not, but cos of x is just sine of x shifted over a bit. It's shifted over pi over 2 because when you look at the x-coordinate on the unit circle and the y-coordinate, they're always, in terms of a 0 to begin with, they are pi over 2 apart. So we can put any real number. We can put -1 is less than or equal to y, which is cos of x, which is less than or equal to 1. What are the intercepts? Well, this time, and I hope this makes sense, the intercepts here were separated by pi radians, weren't they? Let me highlight some intercepts. Here is an intercept, here is an intercept, here is an intercept, here's one. These are all pi radians apart. But since on the graph of sine, the first intercept was nothing, we could just say all the intercepts are multiples of pi. We can't do that here because the first x-intercept is not at 0, it's at pi over 2. And then they are all separated by pi. So for me to describe the x-intercepts, I'm going to say, well, it's pi over 2 plus multiples of pi. Where n is an element of the integer number set, and your y-intercept, of course, is 1. The start point of cosine is 1. Bless you. Maximum and minimum, y max is 1, y min is -1. Am I going too fast here? You're with me? Okay. Well, the period is the same idea whether it's cosine or sine. How far does it take horizontally before it repeats? Well, if you look up here, I guess one period would be the following. Up, down, down, up. I went through 4 pieces. So how far is it from here to here? Well, that distance is the same as from 0 to 2 pi. It's 2 pi. And I could even demonstrate that by starting here and going down, down, up, up. This should be curvy, but you get my drift. So the period is 2 pi. What's the amplitude? It's 1 as well, same as sine. There's nothing that's really changed except for the intercepts. So the period is 2 pi. The amplitude is 1. If I draw the amplitude on there, I can draw it in a lot of places. This is the amplitude. This is the amplitude. Just a couple of final notes before we get into the stretching and reflecting. These graphs would look the same if I used degrees. If I whited this out and put 180 degrees and 360 degrees, it's the same graph. Secondly, if you're ever stuck, you can always graph them on your calculator, but pay careful attention to how it's done. You go into y equals and you put, say, sine of x. And there's going to be exceptions to this, but I want everybody to do this right now. Don't worry about what mode you're in. Go sine of x. And then go zoom trig. And it won't matter which mode you're in. Your calculator will look to see what mode you're in, and it will create the graph for that mode. It looks like that. Now just hit your mode key. How many of you were in radians? How many of you were in degrees? It looks the same though, doesn't it? However, if I, for some reason, I'm doing some calculations and I change my mode to degrees or to radians, and then I'm doing some stuff and I go, man, I want to look at that graph again. Because now my calculator is compiling the data points by using radians, but when I went zoom trig in degrees, look at what it changed the window settings to. Negative 360 to 360, basically. I don't know why it doesn't actually go negative 360 to 360, but it did that. How many of you had your calculator in radians? Look at your window settings right now. They're at about negative 6 point something to 6 point something, which is negative 2 pi to 2 pi. And I'm guessing if you changed your mode and then looked at your graph, changed your mode to degrees and then looked at your graph, you're going to see a horizontal line, aren't you? So if you ever see something funky going on with your graph, you need to re-zoom it in trig mode. You need to go zoom trig. Okay. All right. Listen, what A and B did before, do here. So I'm not so sure we need to draw everything. I'm going to start by drawing things, and then we'll weasel our way away from that. You know that cosine, everybody, if you look up here, you should know that cosine starts here and goes down. Cosine starts at 1 and goes down. And I'm not so sure you need to plot that point, because that's not the graph we're after. You also know that cosine has a maximum value of 1 and a minimum value of negative 1. Are you with me on that? Okay. What does... Is that what you were going to tell me? Thank you. You also know, let me draw that in, that cosine starts at 1 on the y-axis and goes down, and it oscillates between 1 and negative 1. You should know. The only thing that 2 does when we multiply cos by 2 is it stretches things vertically by a factor of 2. All these x-intercepts, are going to stay the same. The only thing that's going to change is this is going to go down to -2, this is going to go up to +2, and the start point will be there. Now, what's the period of cosine? 2 pi. What that means is, if it starts at the top, it's going to return to the top at 2 pi. Now, how many of you were kind of trying to follow what I was doing when I picked these 2 points? Okay, so I won't worry about it. I know that from here to here is 1 period, but I know that 1 period is 4 pieces. So what I'm going to do is spatially break this up into 4 equal pieces. From here to here is 1, from here to here is 2, there's the third, and there's the fourth. That means if it has to go from here all the way down to the bottom and back up, it's going to hit the bottom halfway. It's going to hit the x-axis halfway again in between those points. And you're not going to draw this with a straight line, right? You're going to draw it, you're going to be curvy about this. Curve, 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 curve. If your graph doesn't look pristine, don't worry about it. You'll get better at it. And if you want to continue in the opposite direction, you certainly can. This is just a matter of kind of a visual pattern. Down, down, up, up. What were we asked for here? We were asked for, I just want to look, did I give you, I did give you a box at the bottom, right? Domain, range, amplitude, period. Domain, range, amplitude, period. Are we okay with those 4 statements? The amplitude is 2? Yep. Thank you. Thank you. And I totally botched that anyway with the y. -2 is less than or equal to y, which is less than or equal to +2. Thank you, Annalie. I think a couple other people saw that too and were wondering. It definitely goes from the minimum to the maximum. I mean, you know, the goal would be that if I looked at B, you should be able to tell me that the amplitude is 3. Because sine x starts here and goes up. Sine x goes up to 1 and down to -1. And it repeats in both directions. That -3, the 3 part of it multiplies the vertical components of the graph by 3. What's going on here? Multiplies the vertical components of the graph by 3, so it's going to go 3 above and 3 below the middle. Sine starts in the middle going up, but the negative reflects it vertically, so it starts in the middle going down. The period is still 2 pi. It has to go through 4 chunks. Starting here going down, then going up, then continuing up, then going down. And there's arrows on the end of each of these, and it continues. So what is the domain? Any real number. The range is -3 is less than or equal to y, which is less than or equal to 3. The amplitude is 3, and the period is 2 pi. -1/3 cos x. Well, let's cut to the chase. I don't think we need to sketch this. You could do it on your graphing calculator if you like. I'm going to just put in the boundaries if it were cos x. Since things are stretched vertically by a factor of 1/3, the maximum and the minimum change from 1 and -1 to 1/3 and -1/3. This graph, just so you know, where does cosine start? At the top. this graph will start at the bottom because it's been vertically reflected. You don't have to sketch this. I'm going to. That's what it would look like. Do me a favor, take 10 seconds or so and write out what the domain, range, amplitude, and period is. You can check with what I've written. We okay with that? So would you be able to write out what the amplitude, range, domain, period, all that is for this one without even graphing it? I mean, you do need to know how to graph these, but ultimately you need to go beyond the concrete and go more into the abstract. I hope you're appreciating that the amplitude will always be A, little a. And if little a is negative, don't use the negative when you talk about amplitude. The domain of all of these is any real number. The range is, in this case, -1/2 to 1/2. The amplitude is 1/2. The period is 2 pi. Quick question for you to ponder. Will this always be true? It is for every one we've looked at. And if you're willing to commit to saying it's not always true, can you give me an illustration of when it would not be true? Grace, do you have an idea? Right. And I like that you said D instead of K. When you apply D, which is a vertical translation, if we were to shift this thing up or down, then the maximum would not be A, it would be A plus whatever that shift is, or A minus whatever that shift is. The period in every one we looked at was 2 pi. Is it always going to be 2 pi? Annalie, what would have to happen to change the period away from 2 pi? Right, if it's stretched horizontally, either increasing in size or decreasing, whether it's an expansive or compressive stretch, it's going to change that. And that leads us to this. What does the graph of y equals sine of 2x look like? Well, I'm actually going to sketch sine of x on here in the hopes that you become very familiar with y equals sine of x. It starts at the origin, it goes up to 1, down to 0, down to -1, back up to 0. That's what y equals sine of x looks like. So what will sine of 2x look like? We know that when you introduce a b value of 2, that there is a stretch factor by the reciprocal of that. You also know that any point that's on the y-axis will not be affected by a horizontal stretch. What this in effect does is it takes this graph, and I know if you're watching on video, am I recording this? I guess I am. If you're watching on video, you can't see this, but what we're doing is we're taking this and we're pushing it in by a factor of 1/2, which means the period is not going to be 2 pi, it's going to be pi. And what that means is this graph is going to start here and go through a complete cycle to there. So I have to split that horizontal distance into 4 equal chunks. It's going to go up to here, down to here, continue down to this point, and back up to the top. So it looks something like that. And it's going to repeat, and we don't need to draw it over and over and over again. So the domain is any real number. The range is -1 is less than or equal to y, which is less than or equal to 1. The amplitude is 1, and the period this time is 2 pi. Well, I don't want to do that just yet. The period is pi. Would you agree? Okay. This graph is a cosine graph which would start at the top and finish after one period at the top. But this thing is stretched horizontally by a factor of 1/3, which means instead of going to 2 pi, it's going to go to 1/3 of 2 pi. The period here is going to be 2 pi over 3. Well, 2 pi over 3 is 2/3 of pi. It's to here. Right, this distance from here to here is pi. There's 1/3 of pi. There's 2/3 of pi. I have to draw from that first brown point a curve that goes down and then down below and then up and up above. So it's going to reach the bottom halfway. It's going to cross the x-axis halfway. And halfway. It's going to look like this, approximately. And from that, you can certainly write down what the period, domain, range, and amplitude are. X is any real number. -1 is less than or equal to y, which is less than or equal to 1. Amplitude is 1. Now I want to show you something. Would you agree in this question that b is 3? Yes? Okay. Would you agree the period is 2 pi over 3? Would you agree in this question b is 2? Would you agree the period is 2 pi over 2? Two pi over 2 is pi. The period's always 2 pi over b, which kind of makes sense because you're dividing by b, which is the equivalent of multiplying by the stretch factor. So let's try f and g, or g and h rather, without actually writing out a graph. What is the domain? I hope you understand that we can't do anything to these graphs to change that fact. It's any real number. Since we have a coefficient of 1 in front of sine, the amplitude is 1. Since the amplitude is 1, the range is from -1 to 1. And the period is 2 pi over b, which is 2 pi over 1/3. And if I multiply the top and the bottom of this fraction by 3, I get 6 pi, which if you think about for a minute should make sense. Sine of x has a period of 2 pi. B is 1/3 here, which means we're stretching things by a factor of 3. 2 pi times 3 is 6 pi. Finally, and I'm not going to exactly race through the examples after we're done with this, but you should be able to do the examples very quickly. Lucas, what's the domain of this function? X is any real number. Thomas, what would the range be? The range. -1 to 1. You'd write -1 is less than or equal to y, which is less than or equal to 1. What's the reason, Carly, why it's -1 to 1? What in that function is telling us -1 to 1? What's that?
Because we learned the graph from before and remembered it.
Right? But why? But cosine goes from -1 to 1. Why didn't that change in this one? Right. The coefficient A is 1. So where I'm really going with this, I've already told you that the period is 2 pi over b, and let's put absolute value signs around that. And what I think I've told you is the amplitude is that. This is all about A and B today. That's all we're doing. -1 is less than or equal to y, which is less than or equal to 1. Olivia, what's the amplitude? It's 1. And what's the period? It's 2 pi over a half, which is 4 pi. Right? Multiply top and bottom of this little beast by 2, and these cancel, and you're left with 4 pi. That's, that's it. That's the lesson. Now we're just going to run through some very quick examples. So at the top of the next page, there's the summary. We shouldn't need to graph it all the time. You should be able to fill in these 4 blanks in under a minute or so. The only one that might require a little bit of thought is the period. So I'll give you a minute to fill them in, please. Is this as simple as it seems it should be? Okay. I just don't want to, assume too much. The period is pi because the period is 2 pi over b. Do you understand why I'm using absolute value signs even though I don't need to here? If b is negative, I don't want to say the period is negative. B is 2, so this is 2 pi over 2, which gives you pi. By the way, all of the examples I've done so far, I think, are using radians. I could have asked for the period in degrees, and the answer would be 180. So when I say the period is 2 pi over b, I could say the period is 360 over b. Any questions with 2a? Okay. Is there a b? Oh, there it is. The amplitude is 1/4. The range is -1/4 to +1/4. The domain, of course, is any real number. The period is 2 pi over a half. I mean, sooner or later, you should be able to see that that's 4 pi. You shouldn't need to, multiply top and bottom by 2 all the time or multiply by the reciprocal. All right, one last one. Determine an equation. Sorry, 2 last ones. What's an equation of a sine function with the following properties? This is really almost a multiple choice question. If I gave you the following, I won't even do that yet. If the amplitude is 4, that means we can use A equals 4. Now I want to talk about this. If you rearrange that for B, what do you get? If I said rearrange this for B, what is it you get? Not in this question. I'm not asking in this question. I'm saying algebraically rearrange this for B. Well, if you cross multiply, you get KB equals 2 pi, which means B is 2 pi over K. The relationship between 2 pi and K to get B is the same as the relationship between 2 pi and B to get K. If you know one, you divide it 2 pi by it to get the other. So B is 2 pi over 90 degrees, but we better use degrees here, right? That's sloppy math. Let me make my point properly. You get my drift? Okay. So B will be 360 degrees divided by 90 degrees. B is 4. And how many of you knew B was 4? How many of you knew it was 4 because you thought of a stretch? Yeah, and that's very often when you find B in your head, you're thinking stretch, but you can do it algebraically. Bottom line is this is an answer to the question. Y equals 4 sine 4, I'll use theta. Can you come up with a different function that's a sine function that still has those properties? Y equals negative 4 sine 4 theta. That's why the question says determine an equation. If the amplitude is 0.5, then it's y equals 0.5 sine. If the period is 6 pi, I'll just ask you, because it's you do that double thing where you fake yourself out. What number goes in front of the theta? Yes. And I did this by thinking of stretches. To go from 2 pi to 6 pi is a tripling, is a stretch factor by a factor of 3, so B is a third. If you did it using this, then you would get 2 pi over 6 pi, which is a third. Final question, we have to come up with the equation of this graph. And we're given a hint here, it's a cosine equation. So everybody identify on this graph what the amplitude is and what the period is. I'm not asking for A or B, I'm asking what is the amplitude of this graph, what is the period of this graph? I'm getting 3 for an amplitude and pi for a period. And for the pi for a period, I like to start at 0. I don't like to try to figure out what that is. I like to start at 0 and see that I have to go up, up, down, down. Oh, that's pi. So that would mean that B has to be a number that stretches 2 pi, that produces a stretch factor that changes 2 pi to pi. So if you're thinking in terms of stretches, we have to stretch by a factor of 1/2, which means B is 2. If you're thinking B equals 2 pi over the period, that's almost easier. You're going to take 2 pi divided by the period of pi and get 2. Y equals 3 cos 2x. Not correct, right? What little correction needs to happen here? Annalie? Right. I need to move that start point from above where it starts with cos to below, so that's the answer to the question. I feel as though, did I go too slow here? It was okay. Just a long lesson. I'm only giving you about between 10 and 15 minutes to work on this, but really, you guys, it boils down to this. What we're going to do tomorrow is amp it up a bit and look at the horizontal and vertical translations, which we use C and D for. Many of these textbook questions ask you to sketch a graph. You do not need to sketch a graph, but you need to be prepared to sketch a graph on a written response. Okay, so get to work on those, and I will come around and give you a hand.